getting, for example, heads, tails, tails. What is the B? Tails, heads, tails. So what's one or the other? Well, the formula says you simply add them together and you subtract out the overlap. Now, is there any overlap? Can you have heads, tails, tails at the same time you got tails, heads, tails? Impossible. It's either one or the other. So the overlap basically is 0. And therefore, the formula, if you see, basically it says if you want to get the probability of something, you just add together the separate probabilities. So it's one out of, so what I'm trying to say, maybe in a slightly not clear way, is that this is 1 out of 8, this is 1 out of 8, this is 1 out of 8. So what's the chance of one or the other happening? Well, the answer is 3 out of 8. I mean, I think that's a common sense result. And I think I will pass it back to Will, please. Okay, so that's the answer. That's got to get 3 out of 8. But that's still not, so the answer is 3 out of 8 by using the method, which I think I erased, how many ways you can get the event, how many ways you can get the sample space, and there are 3 ways you can get exactly one head. These are the 3 ways, and there's 8 ways of getting something in general, so it's 1 out of 8. That's still using the old methods, either doing this formula here in essence, or even going back to the more simple formula, 3 out of 8. But I want everybody to first of all realize the answer is 3 out of 8. And we can actually do it. If I told them, take out 3 coins and throw them down right now, and we keep track and do it 25 times and keep track of everybody's result, it should come out to roughly 3 out of 8, or about 37%. But it's still not the binomial distribution formula, so we still have to develop that formula. So the binomial distribution formula is based on is going to be a combination of the multiplication method that we saw early on over half times a half times a half. We're still going to do that, but it's going to be combined with the combinations that we had learned about in chapter, like 4 choose 2 or 3 choose 2, that kind of thing, from combinations from chapter. Those 2 things together is going to come up with the binomial formula. So let's develop it step by step. So again, like always, I can just show you the formula, teach you, well, there are 3 numbers you got to plug into the formula: the n, how many coins you have, the chance of a head, like 50-50 or 60-40, and the third thing you got to plug in is how many heads you're looking for: 1 head, 2 heads, or 3 heads. I can teach you the whole formula in 60 seconds. You plug it in, calculate, you get the answer, and that'll be useful to some extent, but I don't think it'll be really part of your education. So I'd like to develop the formula with you to see where it comes from, so when you apply it, you have a better chance of getting it right. We're focusing now on this part of it, the chance of getting exactly 1 head. We're focusing on that right now. And we're going to do that by picking a typical sequence that looks like where you get exactly 1 head. And the typical sequence will be head, tails, tails. Now, this is not the only way to get 1 head. You can get tails, heads, tails also with tails, tails, heads. But let's pick a simple one, heads, tails, tails, that represents not the whole thing, but one part of the problem of getting exactly 1 head. Now, what is the chance of getting head, tails, tails? Raise your hand, please. Yes?
1 out of 8.
Now, the answer, of course, is 1 out of 8, because there's only 1 of them out of 8. That's one answer. Or, slightly more sophisticated, and turns out to be more useful to us. I'm going to pass it back to David, I think. Is to do it, besides knowing the answer is 1 out of 8, the chance of this happening is 1 out of 8. We know that from just looking at it. This is here, 1 out of 8. But also, you can use the multiplication. What's the chance of getting a head? It's a half. What's the chance of getting a tail? Also a half. What's the chance of getting a tail? And what's the chance of getting heads followed by a tail followed by a tail? It's a half times a half times a half, 1 out of 8. So either way you look at it, the answer is 1 out of 8. But what was our original answer? The original answer was 3 out of 8. So it doesn't match up. Can somebody explain to me and the rest of the class why are we getting the answer 1 out of 8 over here? But I told you the answer should be 3 out of 8. Somebody else besides Nate? Yes, David?
Because you're multiplying?
No, we're doing a half times a half times a half, comes out to 1 out of 8. I'm asking you, where does the 3 out of 8 come from? Why is the answer 3 out of 8? Yes, John?
Because you're looking for the head in the first place.
Okay, I think you answered my question first. This is for you, and this is for you. Yes, Adisa, what are you going to say?
It's because that number right there represents how many times you'll get 1 head and 2 tails, not.
Okay, that's what Johnson just said. So let me just repeat it. Because you got to be sensitive to the fact that we're talking about 2 different but similar and related problems. This question is saying, what's the chance of getting a head followed by a tail followed by a tail in that particular order? And the answer is 1 out of 8. This example is saying, what's the chance of getting a head in any order? The head could be at the beginning, the head could be in the middle, the head could be at the end, but there's still going to be one head and 2 tails. So that, of course, is more likely because you have more chances of that happening. So the answer is going to be 3 out of 8 instead of 1 out of 8. So let me just see how to explain that. So the question is, so the chance of getting heads, tails, tails is 1 out of 8. But is this the only way you can get exactly one head? The answer is a couple of people just said, and most of you probably realize, is no, you can get the head at the beginning, the head in the middle, and the head at the end. So the question is, we have 3 of these, so we've got to multiply it by 3. So the final answer is 3 out of 8. And we're instead of saying multiply by 3, we do 1 out of 8 plus 1 out of 8 plus 1 out of 8, which is the same thing as multiplying by 3. Comes out to 3 out of 8, and we get the answer we expected to get, 3 out of 8. And again, if you actually physically did it, you'll see it comes out to about 37% of the time, which is 3 out of 8. So the question is, how can we change this into a formula? So let's make a couple of changes. Instead of calling this a chance of a head a half, I'll call it a half. For the chance of a tail, I'm going to call 1 minus a half. Is 1 minus a half equal to a half? Yes, of course. Because when you solve a problem like this, they tell you the chance of a head is 30%. So what's the chance of a tail? Obviously 70%, right? 70%. So I don't know why everybody wasn't raising their hand for that one. Okay, the chance of a head is 30%, the chance of a tail is 70%. So instead of talking about the chance of a head and the chance of a tail as 2 separate numbers, one is really a function of the other. Once you know the chance of a head, the chance of a tail is the opposite, with the complement of 1 minus a half. So I'm going to write it this way. Okay, and I'm going to write this 1/2 raised to the 1 power. Now 1/2 to the 1, anything to the 1 power, to remind you, is the same thing, doesn't change anything. But I'm going to write 1 minus a half raised to the 2nd power. Why is there a 2 there? Because there are 2 tails. Tail times tail, so it's tails times tail. Except I'm not going to write this as 1/2 raised to the 1 power and 1 minus a half raised to the 2nd power. I'm going to write this as the 3 minus 1 power. Why 3 minus 1? Well, 3 minus 1 is still 2. I didn't change anything. But 3 minus 1 shows you that we're starting out with 3 coins, and one of them has to be a head, because we're talking about the chance of exactly 1 head here. So how many tails do there have to be? Well, 3 minus 1 is 2. That's why you know there's 2, because this comes in handy when you have like 27 coins and 15 heads. You want to have a formula that sort of puts it all together for automatically. So what do we see so far? If you're developing a formula for calculating the probability of 1 head and 2 tails, you got to put down the chance of a head, which is a half, raised to what power? Well, it depends how many heads you have. If you have 1 head, it'll be a half just 1 time. If you have 2 heads, it'll be a half times a half. So it'll be a half to the power of the number of heads, which in this case is just a 1. The chance of a tail is 1 minus a half. And how many tails are there? Well, if there are 3 coins, and one of them is a head, 2 of them got to be tails, so it's tails times tails, or something to the 2nd power. And later on, for example, if I change the problem so the chance of a head is not 50%, but 30%, I put a 0.3 here, and a 1 minus 0.3 is 0.7. So that'll be a simple change to make right over there. But can somebody do this count? How much is 1/2 to the 1 power, 1 minus a half to the 3 minus 1 power? After all is said and done, what does that boil down to? What is this answer? What is this equal to? And don't try to guess it, just do it if you know fractions. Miss Laura? Well, yeah, this comes as a half times a half times a half, comes out to 1 out of 8. But we're still not, so this formula, which gives us a large amount of understanding of how to solve the problem in general, still doesn't give us the right answer. It's missing one piece, because somebody sort of guessed, and we're now already, the other stuff I guess was easy. Now I'm asking a hard question. What's the piece that's missing? What's the piece that's missing? In other words, we got to go from 1 out of 8 to the final answer we know is 3 out of 8. So yes, David.
3.
Okay, you got to somehow throw a 3 in there. The question is, where does that 3 come from? Why 3? Why not 17? Why not, so you got to tell me why. So you're right, 3 is the right answer, but why is there a 3 there? Yes?
You're flipping 3 coins?
If you're flipping 100 coins, you wouldn't put 100 here, because 100 times 1 out of 8 would be 100 out of it with more than 100%, so that wouldn't work. So you're not simply multiplying by the fact that we have 3 coins. Even though 3 coins is part of the answer, why there's a 3 there? It's not the whole answer, it's part of the answer. So it's not this view, David, is for, what's your name? Anthony, thank you. Yes?
How many heads it would come up individually, like
The end, I think I understand what you're saying. Let's pass it back to Ada. Okay, what Ada's suggesting is the fact is, the 3 comes from the fact that we have 3 coins. And in this particular example, we're looking for exactly 1 head. But maybe do it over here. We're flipping 3 coins. And we have to, in order to satisfy the event that we're trying to find the probability of,